it so we can build it. Put everything all together, looks like this. The request comes, the ship, the system, or whatever it is, comes from the bottom, goes through the system, and then the end user and the classifier and the authorities are going to look at your design, purchase it, approve it, or disapprove it, or allow you to enter the jurisdiction of the water, or to be used in that particular state. This is the whole thing. But is this enough? Is this because if you are a part of this system, as I said, you can easily get isolated to one aspect of delivering that particular system. The whole question comes, question of sustainability, and this word has been used all over the place. I didn't put the word sustainable in the title of the presentation because there are so many different definitions of sustainability that would have deterred you from being even interested in this lecture. The word sustainable has been used and abused. If you go to dictionaries, if you go to the United Nations website, the word sustainable has been defined by different people. If you talk to the people who are involved in the food, they say sustainability is only about food for the people. So if you talk about the green parties, they only talk about emissions and the clean air and the water. So to them, sustainability means what makes them sustainable. We talk to the ship owners, they say, I should be sustainable. Have enough money to pay the salaries of the engineers who are working for them. So the word sustainable, I said, probably is the most abused word ever in English, and in particular in our particular discipline. In Newcastle, they have put together a group, and then we looked into, can we define sustainability first of all in a way that it is applicable to different parts of engineering and different parts of science and different parts of society and different parts of government and governance structure. We came up with three things. That a sustainable thing, whatever it is, must be enough, must be for all, and must be forever. And the whole target of sustainability is that it has to make us good ancestors. This means the future generation are not going to hate us, and they're not going to swear at us. As if those people who lived 10 years, 20 years, 200 years before us, they don't ruin the earth. Again, we are in the danger of putting this next to the food. The food must be enough, the food must be for all, and food must be forever. No. We would like to translate this to anything you want to do, even to yourself when you wake up in the morning. Am I sustainable today? Is the car I'm driving is sustainable? Is the food I'm eating is sustainable? Is the technology I'm using is sustainable? And I want to define this, let's say, about the ballast water management system. A ballast water management system must be designed to be good enough to treat the water at the flow rate, at the size of the ship, at the emission profile which is required by that one. It must be designed good enough to meet IMO criteria, Classification Society criteria, and many other technological criteria. It must be strong enough to withstand the damage on board the ship. It must be powerful enough to take the flow rate of that particular ship. So you can see the word enough comes only in the spec of the ballast water management system. For all, it must deal with all the sea waters around the world. The best ballast water management system is the one which can be fit on board all the ships. It could be operated by all marine engineers. It could be sold and repaired by all shipyards and installed by all shipyards. This is the target. Whether we can achieve it or not, we don't know. And it should be forever. Forever doesn't mean it should last 200 years. The ship doesn't last 200 years. But the definition of forever means it should not pollute the environment more than the amount of environmental protection it wants to offer. It should not pass the environmental problem from one corner to the other one. This means it should not deal with the issues which we are not unaware of yet, in a way that is going to damage the environment. And also, it must be sustainable on board that particular ship in a way that it should not either outlive or be short-lived compared to the life of the ship. So each one of these could be defined quite specifically for a ballast water management system. And of course, if you treat your ballast water, it's going to make you a good ancestor, because you're going to keep the fish for the future generation to be able to eat fish and chips if they want to, or to eat the nice fish that we had last night. So if this is the target design, it's a holistic view. If I translate the enough for all forever for a ballast water management system, and in a more general way, an engineering system, if this is the target I would like to achieve, first of all, I have to meet IMO's guidelines. In this particular case, it's called G2 and G8 and G9. I don't want to go to the details because there's a paper this afternoon I'll explain what they are. But these are the IMO governing lines about design of this system. Then the next one comes. Is it installable? Can I install it easily on board ships? Is it producible? Can this be produced around the world? Because if you can only produce it in one place and sell it the other place, it doesn't make it sustainable. You can't run your business. Is it controllable? Can I make sure that it can operate on board the ship under the supervision of the engineers? Is it serviceable? If anything goes wrong with it, can I handle it on board the ship? I have to stop the ship in the middle of nowhere. Is it repairable? Can I repair the ship? Can I get the spare part that I want? Supportable. Whether the people who sold it to me are able to come and help me to operate it, to repair it, or to support it. Can it be monitored? Can I monitor operational parameters which are required to operate that particular system on board my ship? Is it durable? Does it last on board an ocean-going vessel? Is it going to take all the pressures, all the vibration, all the heat? Is it reliable? How often is it going to go faulty? And how often I have to stop unloading and loading my cargo because my ballast water system is not working? Do I need redundancy? If the system cannot be operated at some point, do I need additional parallel systems like the other systems on board the ship? Is it robust enough to be able to take different type of water and different type of environments and different type of species? Can it be easily operated? Just press of a button, press of the other button. Does it make life difficult for the people on board the ship? Is it going to have radioactive radiation, or does it have a huge temperature difference between the system and the other pipes? Does it make life difficult for the engineers on board the ship? Is it compatible with the other system in terms of the voltage, in terms of the area which is going to be installed? Is it going to damage the other system which is next to it just because it operates at a different operational condition? Is it affordable? Affordable goes for capital cost and operational cost. Is it cheap enough, or is it expensive? Is it environmentally friendly? Is it going to cause more damage to the environment before it's going to solve the other problem? Is it going to produce chemicals to the water? Is it going to radioactivate the water, which is going to be again harmful to the environment? Is it safe to operate? Classification societies are going to look into that in particular. Does it fit the mission profile of that particular ship or the large fleet of ships? So this is another important factor whether the system which is going to be installed on board that ship. And finally, does that meet D2? We started with D2G8, we're going to end up with D2G2. G2 is the part of the convention which talks about when the ship arrives in your port, whether it has complied with the IMO regulation or not. So you go on board the ship and take a sample of the water, and whether that sample meets the IMO criteria or not. So we start with the design which is G2, and then we end up with D2G8, and we end up with D2G2, which means end of the operation. Whether the systems have reached that point or that target, reaching that target, this means absolute sustainability. It's difficult to get there. You have to go round and round of design. Similar to the ship design. You have to go probably many, many times around that circle to get the final solution and to get the best solution. And there have been some designs which could fall into that category, or over there, or over there. Have we hit the target yet? No. So none of the solutions at the moment meets the sustainability criteria. Well, it doesn't matter, as long as we are close to that target, we are in the right path. Is this the end of this story? You might say, yeah, you told me make it sustainable. Yes, I went through all that circle. Yes, I met all the criteria. But is it the end of this story? No. Marine industry in particular is facing a challenge every day. We have credit crunch one day, and we have the other issues with regulation, with the anti-fouling and incompatibility of the anti-fouling with the other previous resolutions at IMO, and a lot of issues are coming as we go forward. And is life going to get easier? No. You ask an engineer who was operating your ship 20 years ago, I was the one. It was a lot easier. You just used to go to the engine room and do a few operations and come up and then watch TV. Now engineers don't have time even to scratch their head. So this is the issue. Do we have to be ready for the new challenges, and whether our solution